Sustainable ocean energy is a largely untapped resource that has the potential to provide a significant amount of clean energy to meet the world's growing demands. Forms of energy such as ocean thermal energy conversion, waves, and currents can be extracted and used for floating communities, data centers, and even power lines back to land. Hydrogen can also be extracted for boats, cars, and converted to methane for Starship. Ocean thermal energy conversion harnesses temperature differences between warm surface waters and cold deep waters to generate electricity. These systems typically consist of a heat exchanger, a turbine, and a generator. Warm surface waters are pumped through the heat exchanger, where they heat a working fluid such as ammonia or propane. The working fluid is then vaporized and used to power a turbine, which in turn drives a generator to produce electricity. Ocean thermal energy conversion is well suited for powering floating communities, as it can provide a constant and reliable source of energy for lighting, heating, cooling, and other needs. This technology can also be integrated into existing coastal infrastructure and can provide backup power for critical facilities such as hospitals and emergency response centers. Wave energy is generated by the movement of surface ocean waves. Waves are caused by the wind, which creates ripples on the surface of the ocean. This energy can be harnessed through the use of wave energy converters. These devices capture the energy of the waves and convert it into electricity. Wave energy has some advantages over other forms of renewable energy. It is a predictable and reliable source, as the movement of the waves can be accurately forecasted. This form of energy is well suited for powering floating data centers. The energy generated can be used to power large-scale wave energy converters, which can then be used to generate electricity that is fed directly into the data center's power grid. Ocean current energy is generated by the movement of currents below the surface. These currents are large, moving bodies of water that circulate around the world's oceans, driven by a combination of temperature, salinity, and wind patterns. This energy can be harnessed through the use of underwater turbines. These turbines are typically anchored to the ocean floor and are designed to rotate as the ocean currents flow past them. The rotational energy of the turbines is used to generate electricity. Underwater turbines can be installed in areas with strong and consistent ocean currents. Ocean current energy is a predictable and reliable source, as ocean currents are driven by long-term climate patterns. As one of the most abundant elements in the universe, hydrogen is a promising fuel for a variety of applications, including transportation, power generation, and industrial processes. While most of the world's hydrogen is currently produced from fossil fuels, there is growing interest in the sustainable extraction of hydrogen from ocean waters. The hydrogen in seawater is tightly bound to oxygen atoms, making it difficult to extract. The most common method for extracting hydrogen from seawater is through a process called electrolysis. An electric current is passed through the seawater, which breaks the water molecules apart into hydrogen and oxygen. Hydrogen gas is combined with carbon dioxide to produce methane gas and water. Methane is a highly energy-dense fuel that is easier to store and transport than hydrogen. Methane is a preferred fuel for rocket engines, as it has a high energy density and is more stable than other fuels. Methane can be used as a fuel for rocket engines, and has been tested in several space vehicles, including the SpaceX Falcon 9 rocket.